Today we're going to talk about Kubernetes. Kubernetes is a great platform, but let's be honest, it's a beast to manage. So much so that there are even certifications based solely on managing Kubernetes. So it's no wonder that many tools have appeared to make the life of the Kubernetes operator a little easier. My name's Tommy, and in this video we'll go over 10 essential tools for managing Kubernetes. Let's kick things off with kubectl. Anyone with any experience at all in Kubernetes has used kubectl. You'll encounter this tool among the first thing you learn in any Kubernetes book or tutorial. kubectl is the basis for Kubernetes management. With it, we can get information about the cluster and whatever is running on it, deploy and manage applications, troubleshoot applications in the cluster, and manage the cluster itself. In a nutshell, kubectl lets you do everything with Kubernetes. However, it's sometimes difficult to use and not very ergonomic. Thankfully, we are just getting started. As I said, kubectl doesn't have the best ergonomics. There are two ways in which external tools make things easier. I'm talking about kubectx and kubens. These two are installed as a bundle. kubectx lets us switch between Kubernetes clusters with ease. Let's say we have two clusters, testing and production. We can run kubectx to get the list of clusters we have access to. In the background, kubectx uses kubectl to list and switch between known contexts. After switching to one of these clusters, any kubectl commands we type are sent to that cluster. We can switch back to the previous active context with kubectx dash. Moving on to kubens. This is a tool designed to swap between Kubernetes namespaces. Namespaces are like little boxes that help us organize and run applications in the cluster without one interfering with the other. Let's imagine we want to split the application frontend and backend. One way to do this within the same cluster is with namespaces. To create them, we need manifests. We create the namespaces by applying these manifests with kubectl apply. Now we can list the namespaces with kubens. To switch, we use kubens namespace. And as with kubectx, we can switch back with kubens dash. So these two tools work in combination. First, we switch to the correct cluster with kubectx, and then we zoom in into the namespace with kubens. The next one is a tool that became so popular that was actually implemented in kubectl. I'm talking about Kustomize. We can run Kustomize as a separate tool or in kubectl with the -k option. To be frank, it took me a while to understand the problem Kustomize solves. Let's say I have an application I want to deploy in Kubernetes. Basically, I have a set of manifests that I send to the cluster. What happens if I want to run a test or staging version of the same application? I would need to basically duplicate all the manifests and only change a few values. Maybe I change the number of replicas, the image name, or the labels. So we need a lot of duplicated code only to run a test version of the application. Kustomize help us here by reducing the number of lines we need. We can create a main deployment file and then patches for staging and for dev and for testing that are applied to the main deployment file. Maybe an example can help us here. Say we have a deployment manifest for a web application. We call the file deployment.yaml and we put it on a folder called base. Okay, that works, but now we want to create the staging version of this same application. We can use Kustomize for that. First, we need to define a customization.yaml file that references the main deployment. Next, we create the patch file. We put that in an overlays-station folder. This is the station deployment file. And we only define the values that change. For example, the number of replicas and the container image. And then we create the customization file in the same folder. This file references the base deployment file and the patch file. This tells Kustomize how to merge the patch with the main deployment. Then we run Kustomize build to get the merge file, which is ready to apply into Kubernetes. The tool is also embedded into all modern kubectl versions. We obtain the same functionality by running kubectl kustomize or -k. In addition, Kustomize can generate Kubernetes secret and config maps. These resources are generated dynamically, ensuring that sensitive data is separate from other configurations. For example, we can create a secret and apply the secret to the cluster, or we can create a config map from an application properties file, which we reference in customization.yaml, and we apply with kubectl kustomize. Helm is a package manager for Kubernetes. It allows us to define, install, upgrade even the most complex applications. Think of it like apt or yum, but for Kubernetes. In Helm, packages are called charts. The main repository for charts has almost 13,000 charts. You can browse the site for ready to deploy charts, or even use Helm search to search from the tool itself. Once you find the chart you need, follow the instructions to install it. With Helm, you can install, customize, upgrade, or uninstall charts with a few commands. No need to mess around with manifest files at all. K9s is a terminal-based interface to manage Kubernetes. It works on Linux, Mac, and Windows. With K9s, you can navigate your Kubernetes like it's a file system. You can make changes, you can view logs, you can scale replicas, you can deploy applications. Basically, most of the things you can do with kubectl, you can do with K9s. It looks really cool and it has a hacker feel that I personally love. There's, however, a bit of a learning curve for all the shortcuts and features. Kube-bench is your Kubernetes security auditor. From authentication to network policies, kube-bench is a command line tool that checks whether your cluster is deployed to the best security practices. So who decides which are the best practices? Well, in this case, they are defined in the CIS Kubernetes benchmark. You can find them in the Center for Internet Security site, and it's a product of community consensus. You can run kube-bench from the command line or as a pod in your cluster. You can schedule it as a job to get periodical security checks. You can also run it on cloud vendors like Google Cloud, AWS, OpenShift, or Microsoft Azure. Prometheus is an open source monitoring toolkit. It's not just for Kubernetes. You can monitor virtual and bare machines, you can monitor databases and network devices. However, it has great integration with Kubernetes. It can discover services automatically and knows how to pull and store performance metrics and logs from your clusters. Grafana brings your Prometheus gathered data to life. You can create dashboards and track performance of your cluster. That is why Prometheus and Grafana go hand in hand normally. You get the data from Prometheus and show it using Grafana. It allows you to create dashboards, resize panels, and add metrics at will. Both Grafana and Prometheus have alerting systems, so you can create notifications for your team when something goes off. Say you have a big cluster with lots of powerful nodes, which is a great way to run heavy machine learning workflows. But how do you manage these workflows? With Kubernetes, of course, and with the help of Kubeflow. Kubeflow makes everything related to machine learning simple, portable, and scalable. It provides a way to deploy open source machine learning systems like Jupyter Notebooks or TensorFlow training jobs at scale. This is great for things like analyzing vast amounts of data or training AI models. There you have it, a complete toolkit to power your Kubernetes operations. In the description, I leave links to all the tools and a few blog posts covering them in more detail. Are there any tools that I've missed? What are your favorites? Leave me a message. Thank you for watching this video. If you liked it, please consider giving us a like, a subscribe, or a follow. See you in the next one.